So this is lesson number 89 in Algebra 2, conjunctions, disjunctions, products of chords, and secants. Wow, sounds kind of scary, doesn't it? Alright, so let's talk about a conjunction. And if you remember in your English classes, you learned about conjunctions. And conjunctions, a conjunction has the word "and" in it. So when I write a algebraic sentence, and I have negative x minus 3 is less than or equal to negative 2, and x minus 2 is less than 1, and my domain is the set of integers, so counting numbers, 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5, etc., including 0. The word "and" means that both conditions must be met. Okay, so both conditions must be met. And we're going to go ahead and see what those conditions are. So first of all, what we're going to do is we're going to set each one of these inequalities equal to x. So we've got to get x all by itself on one side and x all by itself on one side. So we're going to look at each one of these inequalities as two separate ones. So what we're going to do is we're going to add 3 to both sides. Okay. And then we're going to get rid of this negative. So we get rid of a negative, basically, when it's next to a letter or a number, we just change both sides to negatives, and the sign changes along with it. So as we move the sign this way, or the negative this way, the sign flips around as well. Basically what's happening is it's negative 1x is less than or equal to 1. We're dividing by negative 1, dividing by negative 1, canceling that. This equals negative 1, and whenever you divide by a negative, the sign will switch. So that's really what happened, but I didn't show all of that when I did that. I just looked at it as negative x is less than or equal to 1, and I'm going to move the negative across so my sign follows it, and I get that. And x is less than 2 plus 1, which is 3. Didn't divide by a negative, so x is less than 3. So those are my two solutions. So if I'm going to graph these, and I have 0 there, okay, so x is greater than negative 1. So x is greater than or equal to negative 1. Solid circle to show that it is also can be equal, and it's going to be all the integers bigger than negative 1. So again, I'm making circles there on the integers because integers do not include fractions. Okay, the next part of it is x is less than 3. So this is an open circle, and we have 2, 1, 0, and we go this way. Alright, I guess I shouldn't say that this one right here is an open circle. It's really not an open circle because, I mean, I got the red for this one, and the blue, it doesn't even have to be there because we're talking integers. So the next number that is less than 3 that is an integer is 2, which is what this one is. So there's our answer, and what we're interested in is what do they have in common with each other, because it's the word "and." Both conditions have to be met. Both conditions are only met for those numbers. Because let's just grab one, 0. Is 0 greater than negative 1? Yes. Is 0 less than 3? Yes. It works for both of these. Let's look at negative 1. Is negative 1 greater than or equal to negative 1? Yes. Is negative 1 less than 3? Yes. So the conditions are both met. So that's what a conjunction is. It's an "and" there. Alright? And we'll get into disjunctions in a few minutes, but let's continue on with another conjunction, because conjunctions can be written like this. Okay, notice what we've got, two inequalities, and really this inequality, we could write them separate and. So both of those have to be true statements. But rather than write them split, let's leave them together like that. And what we do then is we're trying to isolate the x. So we're going to add 2 here, add 2 here, and add 2 here. We kind of have 2 both sides. So this gives me 0. This gives me 6. Okay? So now I've got one inequality that could be split up into 0 is less than x, and that's an and sign. X is less than or equal to 6. So let's see what we've got here. We've got our graph. 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Alright, so 0 is less than x. So x has to be a number bigger than 0. Okay? We're not saying how big it is, we're just saying it's bigger. We're also saying that x has to be less than or equal to 6. Less than or equal gets a closed circle, and it goes this way. So what we're interested in is right there for our answer. Parts that they have in common with each other. So the graph that we're interested in is an open circle, a closed circle, and all the numbers in between, because we're going to use as our domain, our possible answers, the set of real numbers, which includes all the fractions. So that's why it's not just individual numbers that we're looking at. We're looking at all of the fractions as well. Okay, so those are conjunctions, and you've done those before. You did them in Algebra 1. In fact, I just got done teaching that in the Algebra 1 class, so I know that you had it at one point, but we cover it again because it's so easy to forget it. Alright, so let's continue on with disjunctions here. And dis means the negation or reversal. Disagree means that you do not agree. So let's look at our disjunctions. Now our disjunctions are going to look like this. Instead of and, we're going to write or. And we'll use our domain, the set of real numbers. Okay, this or means one or the other has to be true. They don't both have to be true, like was in a conjunction with and. Just one or the other. Alright, so we can't put those together. We do them completely separate. So this is going to be x is less than or equal to negative 3, because I divided by negative 1, divide by negative 1, sign switched. So I have x is less than or equal to negative 3, and I also have x is greater than 1, because I'm going to divide by negative 1, divide by negative 1, those become positive, and that goes away, and that switches around. Okay, so if I'm going to do a graph, and this is one of the ways you can look at these graphs and get an idea, is it disjunction or a conjunction? Is disjunctions don't have anything in common with each other, and conjunctions they did. Remember, we are looking at what they both have in common. Disjunctions, we're not looking at that. So we've got x is less than or equal to negative 3. 1, 2, 3. There's negative 3, less than or equal, closed circle, and it's less than, so it's going to go that way. The other one says x is greater than 1. So it does not include 1, so open circle, and it's going to go that way. Nothing in common with each other, and that ends up being your answer then. Alright, so let's look at example 89.4. 89.4 says graph negative x minus 2, and that's greater than or equal to 0, or that doesn't look like, that looks like an arrow more than it does a greater than or equal to. Ugh, they're getting worse. Okay, or what's happening is, see, I try to keep my hand off the tablet because you can't put your palm rested on the tablet or it starts writing, so it makes it hard. And the domain is the set of integers. Now remember, the domain is what are the possible x values. If I say it's a set of integers, that means whenever I put numbers in for x, it has to be one of the counting numbers or negative numbers. It can't be any fractions or anything. Alright, so let's look at this one. Add 2 to both sides. Divide by -1, divide by -1, so those go away and we have x, switch the sign, -2. Let's look at this one. Subtract 3 from both sides. Now again, I subtracted 3, I didn't divide by a negative, so the sign doesn't change when I just subtract. So there's my two inequalities there. Make my handy dandy little graph here. I'm sure your graphs look a lot neater than mine, especially girls. Girls can graph so much prettier. X is less than or equal to -2. So, close circle because of the less than or equal to, and I get a line that goes that way. Alright, problem is we're talking integers. So not only are we going to put a closed circle, but it's only going to be on the integer, so it's not going to be an arrow. Just like that. Alright, x is greater than 3. Does not include 3, but we're talking integers here, aren't we? So the next integer after 3 is 4. Can't be 3, but you can't, there's no reason to put an open circle there because there's no numbers in between here that can be counted. So there's no sense in putting anything until the first possibility, which is 4. Okay, so that's your answer to that one. Alright, so we're going to jump ahead to products of chords and secants, and we'll do that in the next video.